Today's lesson is about factoring more special cases. It'll be pretty short and sweet because we already know how to factor special cases. I'm just adding a step at the beginning, and you actually already know how to do that step too. What we're going to do is first, all of the problems are going to have a greatest common factor that we have to factor out, and then whatever's left over is going to be a special case that we have to continue factoring. So let's just real quick review. What is a special case? One of them would be the difference of two perfect squares, x squared minus 16, and these always factor to x and x plus and minus, and then what's the square root of 16? It is 4. So x plus 4 times x minus 4. Another example, let's look at 4x squared plus 40x plus 100. So if you look here, the first and third terms are perfect squares. So chances are this is going to be a perfect square trinomial where you factor it like a binomial square. The square root of 4 is 2, and the square root of 100 is 10. Just do a double check just to make sure. 2 times 10 is 20, double it to get 40, so it works. So if you remember, that's how you factor special cases. We're going to continue with that idea. We're just adding one step at the beginning of all the problems. Okay, so our first example is 10x squared minus 40. So you first want to look, what is the greatest common factor between your terms? And let's see, they both have 10. So we're going to take a 10 out of each one and then divide each term by 10. So 10x squared divided by 10 is just x squared. And then minus 40 divided by 10 is 4. So we completed the first step. We factored by GCF, but we still have to factor the special case that's left over. And it's always left over inside the parentheses. We still have the 10 out in front. That has to be part of your final answer. And now x squared minus 4, that's the difference of two squares, and that factors into the two binomials, x plus 2 times x minus 2. And then we're done. Okay, next example, 2x squared plus 12x plus 18. First look for the greatest common factor. In this case, they all have 2 as the common factor. So I'm going to write a 2 out in front, and now divide each term by 2. 2x squared divided by 2 is just x squared, plus 12x divided by 2 is 6x, and then 18 divided by 2 is 9. So we have a 2 out in front, and now this is a perfect square trinomial. So that means our final answer will be a binomial squared, and then to get that answer, square root of x squared is x, and then the square root of 9 is 3, and everything is positive. So x plus 3 squared, but we still have the 2 out in front that we took out at the beginning. Okay, here's the last example. Our first step, let's find the greatest common factor. In both of these cases, we have, let's see, 50, 32. I believe the greatest common factor is 2, but if you notice, they both have a variable, so you have to take 2m out of both. And now we have to divide 2m by both of these terms. So 50 divided by 2 is 25, and m to the third divided by m is m squared. And then minus 32 divided by 2 is 16. So we've taken a 2m out, but what's left over is the difference of two squares, so that means we factor it by taking the square root. 25m squared, that would be 5m and 5m, and then 16, the square root of that is 4 and 4, plus and minus. So we factored the special case that was left over. So that is the basis of today's lesson, so good luck.